All right, I think to respect everyone's time, we can just go ahead and get started. You can move to the next slide, Larry, please. All right, good afternoon. My name is April Price with the Tri-County Regional Energy Network, or 3CREN, and I'd like to welcome you all to this conversation about electrification. I am a program manager for 3CREN and really excited about this conversation. And I'll just take a few minutes at the top of the hour here to walk you through a bit of 3CREN background and then hand it over to our guests from Electrify My Home to teach us quite a bit about planning for electrification. Next slide, please. Just a quick reminder of who we are. So we are a collaboration between 3 neighboring counties, San Luis Obispo, Santa Barbara, and Ventura County, and we're able to access ratepayer funds to support energy efficiency improvements within our region. So we have free services for building professionals and households. Next slide, please. So we currently run 3 programs that we are hopefully going to expand to other programs shortly. The top 2 programs on your screen there are mainly for our energy professionals or contractors that we work with. But we're really here today to focus on supporting homeowners in adopting energy upgrades and electrification measures. So we'll be focusing on our home energy savings work, which provides pathways for both multifamily and single-family homeowners. Next slide, please. So the program that I run is our single-family program, and just basically want to give this upfront introduction to our incentive programs so that when Larry goes through all that you can do to electrify your home, you're not scared away by the potential cost of it all. We run a program, and we also coordinate with state and other local programs to really bring down the cost of these measures. So specifically through the program that we run at 3CREN, you are able to access discounted pricing as long as you work with an enrolled contractor. And that enrolled contractor can offer a discount of up to 75% off total project costs. And any project that you do with an enrolled contractor that saves energy, gas or electricity, is eligible for a discount. And the actual discount depends on how much energy that you save. So when we're talking about these electrification projects, as long as you're saving a lot of gas, then you're going to see some attractive discounts from participating contractors. Next slide, please. So in thinking, how much can I actually save? Again, I mentioned our single family program, and those incentives do vary quite a bit depending on the work that you're doing with your contractor. But if you're replacing a furnace with a heat pump as an example project, you might see something in the range of $2,000 off the cost of your project from our program. And then there's some other local and state programs that can be stacked on to that discount in the neighborhood of $2,500. And then we have our federal tax credit that launched at the beginning of this year that will take $2,000 off of the cost of most heat pump projects. So if you're looking at, perhaps an overwhelming upfront cost of something in the neighborhood of $12,000 for a heat pump replacement, it's not unreasonable to think that by stacking these incentive or tax credits, you'll save half off your project. And as long as you work with an enrolled contractor, you'll be walked through those offerings. So with that said, I'm happy to answer questions in the chat regarding incentive programs, but I am very happy to introduce our guest today, Larry Waters from Electrify My Home. And I'll go ahead and just pass it over to you.
Hey, thank you. I appreciate that very much. And we appreciate being part of the 3CREN program. Today, we're just going to talk about how to electrify your home, preparing yourself for the the path forward on electrification. Just a little bona fides real quick. I've been in the HVAC industry since 1982. That's a long time ago for those that aren't keeping track. I'm a NATE certified technician. I have been a BPI certified building science person since 2010. I personally have only been installing heat pumps since 2015. And that was before we really had the word electrification or decarbonization on the tip of our tongues. And I founded this company, Electrify My Home, in 2020, so that we could be an absolute resource for consumers that really wanted to understand the full approach of things. For the agenda today, the introductions which you've had, we're going to talk about validating the switch, kind of the reasons why we would want to electrify. Where do we start as a homeowner? The order of operations, because that's extremely important when you're doing this. And then our process of what we call good electrification. One more thing about us, our mission statement is to provide the most efficient, cost-effective electrification solutions, be a good steward of the electrical panel. We talk a lot about electrifying on your current electrical system, and train and influencing other contractors to do the same. We also do these homeowner workshops for several different utilities across the state as well. So getting the word out for good electrification is extremely important. Really quickly, the basics of validating the switch. So why do we need to electrify in California? So it's pretty easy. We've got pollution goals in California. In fact, the top 10 cities in the country for bad air, 6 of them belong to California, which is pretty crazy if you think about it. So we established a building code that is looking at pollution-free electric heat pumps as a baseline technology. It leads to transition off fossil fuels in the houses. Governor Newsom, about a year ago, the California Energy Commission made a big announcement. It was that in order to meet our goal by 2030, we need to install 6 million heat pumps in California. We only do heat pumps. Last year, we did just under 200 of them. So there's a long way to go. We're not the only people that install heat pumps. A lot of companies out there do it. A lot of HVAC-based companies do it. We're going to kind of guide you on the questions you should ask. California bans natural gas furnaces and heaters by 2030. In the Bay Area, we've just had a acceleration of that. 2027 in the Bay Area counties, you will no longer be able to buy a gas water heater. 2029, you will no longer be able to buy a gas furnace. So if you have some aging infrastructure in your home, or even if you have newer infrastructure in your home, there's going to be a point where you will not be able to replace that with gas anymore. So it's really important to look at this heat pump technology and get an idea of where you're going to ultimately have to go. That's the air quality concern driving that policy. So far, 76 California municipalities have adopted building codes to phase out gas and new construction, whether it be advisory rules or all-out gas bans. This is catching on in a lot of cities across the state, and I wouldn't be surprised if in the next few years it goes statewide. This is one of the transitional plans. This was presented in a slideshow on June 6th of 2019 to the California Energy Commission. And I happened to be on that call. I've been an advocate for electrification and been doing it for a long time. So I was actually doing some advising and consulting with several of the initiatives that have passed to just make sure that they could actually be done in people's homes. We've really gotten down this list, but if we cut all the way down to the bottom here, this is the ultimate goal. This is the 2050 goal, is to eliminate or shut down the majority of the gas system, at least to residential areas and commercial buildings and things like that. We'll see how this morphs itself as we get towards the end, but this is the ultimate goal in California. So we're all going there. We're going there faster than we think. Time flashes really quickly. I've been doing heat pumps since 2015. They were talking about all this way back in 2017. So we are now far beyond that. We are 7 years away from 2030, and that's a biggie. Currently, about 90% of of California homes rely on gas for space or water heating. 12 million houses in California use gas or electric resistance water heaters, which both of those are a great opportunity for a heat pump installation. 11.7 million California homes, 96% of those have gas or electric resistance heating. And there's 3.5 million houses in California with no air conditioning. So probably quite a few in your area on the coastal side with no air conditioning. And we know the climate is changing. There's more and more days every year where we could be comfortable. The beautiful thing about a heat pump is it's carbon-free heating with free air conditioning. So where do we start? Where do we start as a homeowner and a consumer? You should do your own gas assessment and inventory. And you can do this by just looking into your existing gas and electric usage bills, particularly the gas bills. If you're in some of the territories that are covered by 3C RIN, SoCal Gas will be your partner with gas, and analyze your bill. Look and see when it's costing you, what it's costing you. A great way to do that is look at April and May, find out what your lowest bill of the year is, and then look at your highest bill of the year and just realize that's what's going to heating a little colder water and heating your home. So those are the dollars that we can recoup when we're doing the electrical upgrades. If your electric is Southern California Energy or Southern California Edison, you can go to the Energy Manager on their online portal. If they use PG&E, they've got a great resource available with Home Checkup. And if you really want a comprehensive report about your usage in your particular home, all gathered through data, you can go to our website, or you can go to find home energy analysis, or you can go to electrifymyhome.hea.com and you can take the test. They'll send you out a really cool report that tells you when and where you're using your energy. Step 2 would be to build a list of gas appliances in the house. We want to make sure we're thinking of all of them. Even the pool heaters out by you guys, dryers. A lot of people don't recognize that they have gas dryer, gas fireplace, stove, range, water heater, and furnaces. These are all the pieces of the electrification roadmap. There's really eight things in the house that you really concentrate on that could possibly give you a good benefit. And the first one's real easy. Change out those light bulbs, put in those LED bulbs. Look at your stove and oven. If you're a little worried about gas in the house, you can buy portable induction range cooktops for very inexpensive, just off of one of the major home delivery websites. And look at all of these different things. Now, there's various costs that are involved in all of this. So, and these are kind of the high end price of most of the things. But induction cooktops, heat pump HVAC, heat pump water heater is what we're going to concentrate on today. Solar PV, if you don't have it. The economics have changed on solar a bit in the last year, but solar is still a really good investment if you also invest in storage. Electrical panel upgrades may be required as you get further down your electrification path. And then, look at heat pump clothes dryers if you don't do too many loads of laundry a day. So how can you find an electrification partner? It may not be your existing HVAC contractor, so keep an open mind. HVAC contractors in California have been extremely good at working on gas furnaces for years. They're really experts on them, but installing furnaces in houses with gas furnaces, installing heat pumps in houses with gas furnaces is really a very new thing, and a lot of people are still figuring it out. So be careful about who you choose. A couple of things you want to ask is, do they have experience assessing panel capacity? And that means doing a load calculation on the panel. Most electricians know how to do this, and a lot of HVAC companies know how to do that as well. But a panel isn't full just because it doesn't have space. The company should have a familiarity with replacement options for all gas loads. It doesn't mean they're going to sell induction cooktops or induction stoves and dryers, but it does mean that they're going to be able to discuss your options on those. So they're going to have a decent working knowledge of those other gas appliance replacements. So you want to ask that. Find a company that understands the complexities of running additional appliance circuits. A lot of our projects include a heat pump water heater, and running a wire to the oven and running a wire to the dryer. Sometimes just doing a heat pump and running a wire to the new heat pump water heater location, so that when your old water heater dies, you're ready to just slide one in and plug it in. Find a contractor that's willing to do a manual Jake load calculation with room by room airflow if you can. Not all contractors do this, and it's not necessarily a deal breaker, but there are third-party services that you can have do these load calculations. They are valuable in this process if you can find a contractor that'll do one for you. Believe it or not, it's not something that all contractors do. It does take time and a little bit of science. They should have an understanding of maximizing energy efficiency through downsizing. Just basically what that means is somebody that can look at the insulation in the attic and tell you if you need more and how that would affect the sizing of your new system. Find a contractor that has experience installing multiple types of heat pump technology. And we're going to talk about that towards the end of this presentation. You'll get a better understanding. And access to multiple brands. No one brand does it all. There are several contractors out there that handle multiple brands, but it's not a 100% one size fits all with heat pumps, especially. Gas furnaces a little less important, but just ask, if that contractor has access to multiple brands and multiple types of heat pump technology. Make sure you do a little due diligence on these companies and check for reviews. Look at the Yelp reviews, whatever you're looking at, and then look at them a little deeper than just the number of 5-star ratings they have. A lot of contractors have a lot of 5-star ratings for, like, Bob came out and fixed my furnace when it was really cold. That's not going to give you good reference to whether they know how to install a heat pump or not. There's several other ways you can find people, like on Energy Sage, or there's some of the heat pump manufacturing companies like Fujitsu, Mitsubishi, and some of those also have dealer locators that'll help you get that. And those groups are also going to help you find somebody that's probably going to do a little better workmanship, because bad workmanship can really cost you a lot of money. These pictures here, some of them are pretty funny, like the one in the middle, like not having enough material in the vehicle to kind of put the old unit or the new unit down on the ground, so they just pop the new unit up on top. This stuff really happens out there. Obviously, I would think most consumers, if they walked in their backyard and saw this, they would get a little upset. But it happens. We run into this stuff a lot. Or just over here on this side, where just a very much oversized system was installed. Blocking the pathway to me is not a big deal, but this particular house had a bit of a horror story. They put too large of a system in. They put a backup heating system in, and then they put an air handling unit in. So 3 different components that used a lot of space in the breaker box. So when we came back to run the circuit for the stove and put in a new heat pump water heater, they had to get another new panel. They had to get a new panel to get this system installed, and it was only big enough to carry the capacity of this. So they had to invest in electrical panels twice. If they would have put the right solution in the beginning for this, they would probably have never had to put an electrical panel in until they got their storage batteries. So that's important. Not everybody shares the same level of quality, and it's important when you're talking to a salesperson or a company to have them show you pictures of their workmanship. And we would rather see, if we have the same approach, both of these houses are doing the same thing. We have 1, 2, 3, 4, 5 zones here. So one unit here that is doing 5 zones. And over here we have 5 zones as well, but done in a completely different way, like 5 different machines hanging on the back of the wall. So be careful that you understand what they're presenting to you, and that you have a good understanding of what it's going to look like when it's installed. If I had this beautiful house here, I wouldn't want all these lines up my wall. That may have been the only way they could have done it. But if I came rolling up my driveway and I saw that and I wasn't expecting it, I would be a little bit irritated. Even though it looks symmetrical, it's not necessarily pretty. Order of operations. Every house is unique, and we recommend a specific cadence on this. First of all, what you want to check for is get somebody that's savvy on looking for safety issues. The safety issue can change the direction. And this has happened before, where the first order of business was to install the heat pump water heater, and then we come in and we find a furnace that's unsafe. Or we want to replace the furnace with a heat pump system and we find a water heater that's unsafe, or some fluing that's unsafe. You need to make sure when you talk to a contractor that they have the ability to diagnose safety issues, and they will be doing a safety check as part of your electrification plan. That includes things like mold and asbestos, and just rodent damage, or incomplete things like bathroom fans in your attic that aren't hooked up all the way. These things need to be discovered and not buried under construction. So important that the contractor takes a lot of pictures, shares a lot of pictures with you, and you ask a lot of questions. You want them to be able to do an electrical panel assessment. The important things to understand there is, how much service do I have available? What is my main breaker? What is my main power input? And then how are you going to manage that? And can you do it without a panel upgrade? How big is your panel? How old is the panel? And sometimes some of these older panels, like this happens to be a Zinsco panel. These are rather notorious for having issues that can cause burning and arcing. So you want to make sure that somebody's doing a full evaluation of that. And if you have an old panel that's in really bad shape, you might end up getting a panel upgrade, even if the capacity didn't require it. Do you have sub panels in the house? What are the breaker sizes on those? Don't add a circuit into a sub panel unless the circuit breaker that feeds it is adequate of handling the load. And this can help you figure out when you need to do your panel upgrade, if you need to at all. We work in the Bay Area of California a lot, which has a bit of a similar kind of tempered environment that you guys share. And we did just under, I'm looking at my whiteboard, just under 200 heat pumps last year and only had 6 panel upgrades. So it is possible to electrify a lot of this stuff before getting your panel. Our philosophy is let the battery and solar guy do the panel. Pre-wiring. If you have the opportunity to pre-wire, if you're doing a heat pump system now and you're thinking about a heat pump water heater later, inquire with the contractor about running that wire to that heat pump water heater now, so that when that water heater inevitably fails on a Friday evening, you can get a heat pump put in there and you don't have to go back with another gas model because you couldn't get an electrician out there to run the wire. This has saved multiple of our customers over the last few years a real headache. When we get the call on Monday, it's like, hey, you put in that circuit, my water heater finally died, and then we can get out and take care of those pretty quickly. And make sure that you're keeping in mind that most houses in California are going to have an electric car at some point. Addressing the ductwork in the system. We want to make sure that the ductwork is in good shape. Heat pumps and furnaces have different requirements for airflow, and you need to have a contractor that understands. It's not a bad idea to talk to multiple contractors about this. Use some of this information to get the feel for the best one. It's not always the guy that's going to come out that has a nice uniform and a charming personality. That may not be the right guy if they're not, or if they're just taking a peek into the attic or under the floor and saying everything's fine. You really need to do an assessment on the ductwork. Old duct systems oftentimes have very low airflow. Typical duct system leaks about 30%. When we're talking about installing a heat pump that sometimes has 30% or 50% less capacity than your furnace, it's really important that the duct does not leak 30%. Conductive losses. What conductive losses are is when you have ductwork up in a hot attic space and you're running air conditioning or even heating when it's cold, these ducts are going to lose heating and cooling capacity through the surface of the ductwork. it's important that you talk to somebody that kind of understands that and take their advice. If you have one contractor that says you need new ductwork to be the most thermally efficient, and the other two said they didn't want to do it, the other guy's probably not selling you something that you don't need. He may just be giving you better advice, and the other guys don't want to deal with it. Unfortunately, that's the way it works a lot in our areas. And the size always matters. So make sure that the system is sized properly, and ask the contractor, where are you getting the information to size this system, and see if they have a great answer. There's a lot of resources available. A lot of contractors have at least some sort of a load calculation system, and then others don't. But inquire as to how they're coming up with the size for your system. You also want to make sure that you are getting new registers with your system. Heat pumps operate with air temperatures that are much closer to room temperatures. And we want our air to either stick to the ceiling or stick to the wall. We don't want it to blow in multiple directions with a heat pump, because the system is going to run much longer with temperatures closer to the room. We don't want the cooler air blowing on you, because it's not going to feel comfortable. And then through that, hopefully we can figure out the air delivery problems, which are either not enough airspeed, or blowing air right on you. Don't be too reluctant to ask a contractor, do I need more insulation? Can you show me some pictures of my attic? What is your recommendation on that? And maybe if the insulation pictures don't look too good and you think you might need new insulation, maybe try to find a guy that's willing to talk to you about that, or operator, whatever. We want to make sure that cavities inside the attic space. Now, this is from an older home. I think you guys have a batch of these houses out there too, with built-in china cabinets next to the fireplaces. These always leave big holes up in the attic, and these big holes transfer heat. They suck heat out of the house in the winter, and they cause heat to come in the summer, because they're open to the hot or cold attic temperatures. So be careful about that. If you have a crawl space, ask the contractor, are you going to be sealing in my crawl space? Because there's usually big holes under there, and these big holes, when it's cold outside and your house is warm, it'll either steal warm air from the house, or the warm air rising in the house will pull cold air in behind it. So it's a really good idea to seal up some stuff if you have the opportunity to do that. These big holes, we just seal them. We put a piece of foam board over them and then insulate over them. But don't be afraid to ask these questions. Does my house need to be sealed? And then put as much insulation in as you can get in, up to R50. R50 is a great number. That's what this is. This is about 20 inches of insulation. R50 means your attic has to be 50 degrees warmer or colder than the house before any energy is moving through. So on a 95 degree day, when your attic is 125 degrees and you have R50 insulation, you can have your house at 75 and you're not driving any heat through the ceiling. But if you only have this much insulation, which is about R10, anytime the attic is warmer than 10 degrees than the house, it's going to be driving heat into the house. And in the wintertime, it's going to be pulling heat out of the house. So this is an inexpensive thing to do, and it can make things much more comfortable, and it will reduce the operating cost of your heat pump system over the life of the system dramatically. So it's a really, really good investment to insulate. And if you have your ductwork in the attic space, this slide is a good slide if you guys want to gather it. I'm just going to kind of go through it. How much insulation is around those ducts is really important, especially the hotter your attic gets. So in the summertime, when your attic is 125 degrees and your air conditioner is pushing cold air through those ducts that are sitting in 125 degree air, it uses a lot of capacity from the system just to keep those ducts cool. And what we don't want to do when we're putting in a new heat pump is pay for more capacity than we really need. So burying the ductwork with insulation while we're insulating the attic is a really good solution to save energy. In fact, a typical 1,500 square foot house with R3 ductwork is going to use about 14,000 BTUs, or 1.2 tons of air conditioning capacity, just to keep those ducts cool when the AC is running. So just by insulating that attic and burying that ductwork, we can get that loss down to 1,400 BTUs. So basically we save a whole 1 ton of cooling or heating capacity here. And that allows us to downsize the system a little bit, which means a lower initial price. And it also means a much more comfortable home. And then you're getting the benefit of the insulation and the insulated ductwork there. That's over 1 ton of cooling capacity. Typical 3-ton house, when used rule of thumb, is going to have a 3-ton system in it. By just doing this, we've already reduced the need for a 3-ton down to a 2-ton, which is going to use a lot less energy over the life of that system. If you can find somebody that does a load calc, not all HVAC companies do load calcs, and most of them have some way to calculate out the load. If you want to get really precise, find someone that does do this, or call a third-party service that does load calculations and get the load calculation done so the contractor can follow that load calculation. What this is going to just tell you is how much room you need or how much airflow you need in each house, and it helps determine what size system is really needed for your house. And a good example of it is, here's a couple of rooms. They're both 9 foot by 10 foot. One of them is spare bedroom 1, spare bedroom 2. This is the amount of air they need. A cubic foot per minute of air is about the size of a basketball. So this room, to stay comfortable, needs 31 basketballs every minute. This one needs 48 basketballs every minute. They're both the same size, because this one has double exposure. It has 2 walls outside. If you don't take this into consideration, it's gonna lead to a little bit less even temperatures throughout the house. Let's quickly talk about good electrification. Looks like we're on schedule here. Good electrification is a phrase that we coined. And the lady in the boat here is symbolic of taking things at your own pace. Do one thing at a time, or do everything at a time. Look for a contractor that's willing to help you through the entire process. What is good electrification? It's installing the most efficient solution possible. That means putting in the right size unit and putting in a unit that uses the least amount of energy. It's okay to spend a few dollars more for a system that's going to use less energy over time, because almost always you will recoup those costs on the other end of the ownership. As a matter of fact, our systems that we install typically require 25 to 35% less energy over the life of the system, which can amount to a lot of money over 15 to 20 years. Also, good electrification is utilizing the existing infrastructure whenever possible. So that's that whole going back to being a good steward of the electrical panel. And good electrification is also considering all electrification requirements from the start. You really should be talking to somebody that's going to at least consider those other appliances you have, the impact we're making on the panel, and kind of give you at least a basic semi well thought out plan at the least. And electrification can't be done without heat pumps. Heat pumps are magic. Heat pumps move heat, they transfer heat. Gas furnaces create heat. Gas furnaces burn fuel, create heat. There's exhaust that comes out, and there's always losses when we burn a fuel and get a use out of it. There's always going to be some sort of an efficiency loss. In fact, the most efficient furnace on earth is only 98% efficient. It means $100 worth of gas will buy you $98 worth of heat. It's not untypical for heat pumps to be 3 to 4 times more efficient than that. Really quickly, this is how they work. There's a unit inside where you would have a typical furnace. And I don't know the audience 100%, but if you have a typical furnace in your house, this is called the air handling side. So the air handler will take the place of the furnace. If you have a wall furnace or a floor furnace in the house, the air handler would be installed as the air moving device. Then it connects through a series of pipes and goes to the outdoor section. The outdoor section will be called the heat pump, or an outdoor unit. Some people will call it a condenser, and some people will call it an inverter. If you hear someone calling it an inverter, it might be a clue that you're talking to someone that has a little bit more information. But what goes on in here is we have refrigerant gas, also known as freon, traveling through here. Freon reacts to pressure. The freon is pressurized. It gets very hot. That hot fluid goes through this thing. It condenses, comes back really cold, and the cycle completes. Traditional heat pumps that just turn on and off They do suffer a bit when it gets colder outside. So temperatures below 45 degrees, they start losing a little bit of ground and they have to run longer. There is other systems that are better for that. Common residential heat pump technologies are these are inverter style systems. They can come as wall mounted units, something tucked away in your attic space or in your ceiling, or something down low on the floor like an old radiator. A lot of options for this type of unit, but something like this would require a separate unit in each living space. Or you can use the same type of technology with a air handler that will deliver through your existing or a new duct system. The other type is called the unitary. We call them the on and offs. And the on and offs are going to be they're going to use a little bit more energy because every time they turn on, they have to have a big influx of energy to start the motors up. They're typically going to be the ones that are going to warm a little warmer than you're asking for. And if you're asking for 75, they're going to heat up to about 76. And then they're going to cool down to about 74. And you're going to feel that temperature differential. The modulating or inverter units are going to be able to stick to the temperature in the house. So they heat the house up or cool it down, get to the temperature, and they just slow down and run longer cycles. So they have the ability to saturate everything and make the house extremely comfortable because of longer run times. Also, these type of systems with the inverter technology, we can put a really good filtration system on one of these and clean the air anytime it's operating. With this type of arrangement, we are going to give up on our ability to really clean the air as it's moving through the system. Another thing is most of the time, these are going to use 2 breaker spaces, and it's going to be a much smaller breaker. These systems can use up to 6 breaker spaces. So those are things you want to consider as well as you're electrifying. So here's the graph that shows that. So a traditional heat pump system, it's 80 degrees in your house. You want it to be 75. You turn the unit on. It uses a lot of energy to kick over and run, which can really be hard on solar and battery systems. It cools the house off a little cooler than you want it to be, shuts off, lets the house get warm again, turns back on, cools off, lets the house get warm again. And it basically does the same thing in the heating mode. It'll warm up a little more, cool off between cycles. This is no longer the most efficient way to heat and cool a house. It's a lot like having arbitrary stop signs on the highway once you get up to cruising speed and good mileage. Inverter-driven heat pumps, they operate a little bit differently. You turn on that inverter-driven heat pump. It doesn't use a lot of energy to start. It can operate outside the normal 60 hertz cycle range. And so it uses a tiny bit of power to kick over and start running. And then once it's running and establish the flow of refrigerant, then it can ramp up, handle the load in the room a little quicker. But then once it gets to set point temperature, it slows down. And these wavy lines right here are part of the second phase of operation, which is called tempering. This is when you walk into a house that's 80 degrees and you want it to be 75, everything in your house is 80 degrees. When you want it to be 75, we need to get everything 75. So what it's doing here is it's just giving you a little bit more capacity as your furniture and as your walls and wood and doors and floors are all releasing the heat to the room. These units are making small adjustments, but keeping really close to set point. Down here, we see the smoother line. This is once the house reaches the point we call thermal equilibrium. Once the house reaches thermal equilibrium, most of these heat pump systems can run 5 to 6 hours here for every 1 hour here. So with a good heat pump system, it is usually less expensive to keep the house comfortable. Trying to plug and play a system. If you have somebody comes out and says, you got a bad furnace, I can sell you a heat pump right now. I have it in my catalog. Without doing a little bit of extra legwork and having a heat pump installed, it can be not great. We need, when somebody's doing one of these, they need to pay attention to the velocity of the airflow, the temperature of the air coming out. We don't want it blowing on you. The sizing of the system, it needs to be sized right for your house, and it's not always going to be the same. It's never going to be the same size as your furnace was. It just can't be. And it may not be the same size as your old air conditioner was if you have air conditioning. You need to do the panel planning. That often goes by the wayside when we're plugging and playing. And the plug and play heat pump really happens when something has failed and they say we can't make it run again and you want a heat pump, so we're just going to plug the system in there. We need to make sure that people are educated properly. through all this, and not changing the registers in the house, whether it be floor registers or ceiling registers or sidewall registers, to the right kind. I don't know if you already have the right kind or the wrong kind in your house, but the rule of thumb is if your registers blow multiple directions, like 2 ways or 3 ways, those are not the best solution for heat pump systems. Good workmanship saves money in the long run. This is why you got to ask your contractors for pictures of their work. And most of the contractors are going to show pictures of their best work. It's just like all of us do because it looks beautiful. But you want to see things like proper system put in, going the extra mile with the drainage systems. Everything just looks nice and neat and tidy and clean, and they can explain to you what all these pieces are. So when they're showing you these pictures, go ahead and ask, what is that? Is it supposed to be that big? What is this? What is this piece here? Why is it on this stand and my old furnace comes in the side? Ask those questions. You're going to invest a lot of money in this, and you want to make sure you're making the right decision. Don't be worried about hurting somebody's feelings. You need to be an advocate for yourself on this stuff. Right size heat pumps are going to bring really, really big benefits. If the systems are sized right and you choose the right system and it's installed well, you're going to get way better comfort in your home than you've ever had with a gas furnace. I guarantee it. They have to be done correctly. Heat pumps are generally going to be much more quiet if you choose the right system. The inverter technology systems are extremely quiet compared to traditional heat pump systems. You're going to be in a much more environmentally friendly position, which is going to help the state with our carbon reduction and air cleaning goals. Obviously, electric appliances are going to be much safer than a furnace that has fire and can possibly create noxious gas and could potentially have a gas leak in the house. If we eliminate our gas lines in our house and our combustion appliances, our children are going to be healthier, our houses are going to be healthier and safer, and we're not going to risk some catastrophic thing happening that we don't know is happening that could cause people to get very sick. And then you're going to have great indoor air quality if you match a new system with a good air quality device. The rule of thumb for us, I've been in the trade for 40 years, the less fancy the filter, the better off you are. A cartridge filter that has a high MERV rating that you can replace for $40 or $50 a year is available out there. There are really fancy ones that people can get you very emotional about that have wonderful blue lights and shocking electrical pulses and corona fields and all of these things. But all of those are moving part systems that need to be kept extremely clean and lose efficiency very quickly. A really good cartridge filter combined with a heat pump that's going to run longer is the ticket to good air quality. So in summary, and I think we're right on time here for some questions. In summary, electrification isn't going anywhere. Don't try to wait this thing out and say, I'm just going to wait till some other government comes in and changes everything back. We're too far for that. It's that those days are gone. Electrification is here to stay in California. Embrace it and do it properly. Understand as well, early adopters are going to reap the benefits of the carrots. There's tons of carrots out there right now. We were just talking a minute ago about the incentives that are available. Those are not always going to be available. So do the best you can to optimize the incentives. Electrification is not going anywhere. Start by creating a plan. Get your own plan started with the information from the first slides before you start talking to contractors, because you'll be able to figure out the contractors that are worth their salt after you start asking them real questions. Most consumers don't come to the table with any knowledge whatsoever, and those are the ones that get systems that aren't necessarily the best application. Those might be the best system for the contractor, but not the best system for your home. So start creating your plan, get your roadmap together in your head, prioritize safety, make sure that there's going to be some sort of a safety check element in the process that you're going through. If they're going to check and make sure your water heater is safe, if they're just doing the heat pump, ask about pre-wiring, make sure you pay attention to your ductwork. If somebody tells you without doing a comprehensive look and a calculation that your ducts are fine, talk to more people, and just, they may be fine, but you want to have somebody verify that, because sometimes contractors might tell you that they're fine, even though they're not, just because they don't want to mess with them. Do some load reduction, attic insulation, a little bit of air sealing. Go buy some cans of foam at Home Depot and start sealing stuff up. Just don't seal up the vent holes for your water heater. And load calculations when you can get them. Heat pumps are a necessary element, but they must be done carefully. We have 3.7 million houses in California with no air conditioning. When every house in California that doesn't have air turns on their air conditioning during a heat wave, it's going to cause drag on the system. If everybody goes out and gets a really efficient system installed, it's not going to cause a drag on the system, because once the house is cool, the unit's using a tiny bit of energy. So those inverter systems are really good for the environment and the whole electrification plan. So thank you. My name is Larry Waters, and there's our QR code if you're interested. If we have some questions, we can go ahead and answer those now. If we don't have any questions, we can open up a few more slides.
All right. Larry, I'm just going to go through a few of the questions that were in the chat room so far. And then if folks have additional ones, feel free to throw them in there. Barry made a comment that he's paying $5 per month in a customer charge on the SoCal gas bill, even though he may or may not be using any gas. So I was wondering where that charge was coming from. And so the response to that one was that there's a minimum charge on every bill. So if you end up getting to the point where you can actually electrify your whole house, the gas utility will come out and take your meter for you, and you no longer will be facing that minimum charge, which is actually a meter charge. So
yeah, there's also, I mean, if he has already eliminated all of his gas appliances in the house, and he's just down to that $5 charge, that wasn't clear in the question, but if you've gotten rid of all of your gas in your house, definitely call the utility and let them know you've gotten rid of that gas. And there's a fantastic incentive available for you when you replace that last gas appliance. And you could find that incentive by going to the switcheson.com website and look up rebate finder, put in your zip code, and there's one called California Energy Smart Homes. Look into that and see if it applies to your application. And then by all means, tell the electric company that you're using that you've switched to all electric, so they can put you on the all electric rate plan.
All right. Another question came in during that question. Are the gas lines in that house removed or capped? Recommendation.
I mean, we cap most everything we go to, but we also offer a service of removal if somebody is getting rid of the last gas appliance. So I like getting them out. And then at that point, call the gas utility, have them remove the meter altogether. And then there's no chance of having a gas leak in the house ever. But until you replace that last gas appliance, cutting pieces and parts of the gas system away isn't a good idea, because you can cause leaks by sawing the system apart if it's still operational. So we just want to cap them until everything is eliminated.
All right. There was a thread in here about having a tough time finding contractors to do heat pump water heaters. So in SLO County and Ventura. So I mentioned one of the individuals seemed like they were in Ventura County. We actually just did a training in Thousand Oaks. So Helen will be in touch with the name of a few folks down there. And heat pump water heaters are still generally new to the mass market, but a lot of folks are putting resources in getting contractors trained up to be knowledgeable on them. So I think it's still going to take a little bit more time, but especially with an upcoming program expected to launch in September, more and more contractors are going to start offering those services.
That's another benefit as well to the Switches On website. There is a contractor finder on the Switches On, and there's little icons on the listings that tell you what they will do. And I would assume if you didn't see the icon, it's something they won't do. But there are contractors listed in most of the areas that do the heat pump water heaters. And you don't want to have to call 20 people to find the one guy that does. So that's a good resource to find the ones that do that.
I'll just chime in too for the 3C Ren single family program. If you fill out a form on the link that I hope is working now, let us know that you're looking for a water heater. We're continually recruiting contractors that work on heat pump water heaters, and we'll put them in touch with you as they sign up for our program. And just a flag, I am aware that some of the contractors on the switches on that say that they do heat pump water heaters, I filled out incorrectly or something in Ventura County. So just check their website maybe before you call them.
That's interesting. And maybe the switches on should go through and kind of arbitrage all that, or excuse me, and triage all that and figure out who is actually doing it and not. That would be helpful.
All right. Yeah, great point, April. 3C Ren, you guys offers a really great service. They're at the heart of a lot of this transformation. So if you please use them as a good resource. Ann asked a question, one of our favorites, Larry. They got a notice from Edison saying that there might be blackouts this summer. So how is California planning to provide enough electricity and power all the, forthcoming all electric homes and cars? So, I mean, my initial response is, to let everyone on the call know that, the utilities, they have to go through pretty stringent resource adequacy requirements through the CPUC and whatnot, forecasting and delivering load. We've had a few unforeseen issues in the last couple of years that have led to some, blackouts and brownouts. So we're definitely not where we want to be. But there's a lot of eyes on this issue, and a lot of investment being put into trying to get our grid ship shape so that we don't have more issues moving forward. But Larry, do you have any additional comments on that?
Yeah, I do have a couple. I mean, that's a real thing we need to think about. And if the power's out, your air conditioner is not going to work in the summertime. But it doesn't matter if you have a heat pump or a regular air conditioner, neither one are going to work. If the power goes out in the wintertime, people with forced air gas furnaces, those furnaces aren't going to work when the power's out. If you install the right heat pump water heater solution, and I probably should have mentioned this before, we didn't go too much into heat pump water heaters, but heat pump water heaters are available in multiple sizes. Buy the biggest one that will fit, and you're going to be better off. Heat pump water heaters are like a storage battery. You can run them when the power is cheap and turn them off when the power is more expensive. And because they operate that way, they also have large storage tanks. So most of the heat pump water heaters, when the power goes out, you're still going to have plenty of hot water stored. And obviously when the power's out and you know that it's being created by electricity, you'll be a little bit more conservative with it. And then when you're talking to a heat pump water heater installer, also ask for a mixing valve, a thermal storage mixing valve. What that does is it allows you to run the temperature of the tank up and then mix the temperature back down for the house, so it's a safe temperature, but it gives you more hot stored water. And most of the heat pump water heaters out there have a very low ambient loss. So if they're just sitting there, they don't lose much heat to the environment around them. So the bigger the tank, the more you'll kind of the more you'll protect yourself against that situation. But the other thing is, if you can invest in solar and backup batteries, and that's a big investment. And then the other part is, get the most efficient system you can. If like inverter systems that are keeping a house cool are using 1/6 the amount of energy of an air conditioner that is cycling on and off. So the more we get out there that keep the house cool at a low initial amount of energy, the less likely we'll have to do blackouts, because we won't be dragging on the grid as much. So I mean, that's a legitimate question, but they're working on it. They're spending billions and billions of dollars to try to fix these problems.
All right. Helen was asking if you could go into a little bit more detail about how one decides between a conventional heat pump and an inverter, and whether the inverter ones are the ones that give you a unit in each room.
Well, the inverter units are a family of technology, and there's several different types of inverter units, and they don't they can deliver centrally, like they can be hooked up to an air handler and delivered to the whole house, which is the way we install most of ours. We do very few of the wall mounted mini split type situations at our company. And then the regular heat pump is a traditional or a unitary. You'll know when you're looking at these because the efficiency ranges change around 17 SEER, and they'll talk to you about the SEER number. And if they're talking to you about that, that's kind of the air conditioning rating, but it's a good indicator of anything really above that is going to have some sort of an enhancement. And that might be I don't want to confuse you, but that could be an inverter that works off the temperature of the air moving through, or an inverter that works off the temperature at the thermostat. So there's several different types, but anytime you're getting into inverter technology, it's always going to give you a much lower operating cost over time and less demand once the house gets either cool or warm. Cooler or warm. I hope I answered your question.
All right, and if not, just let us know. Let's see, there was a question about panels, which we maybe jump back to in just a moment. But let's go to, are there any materials or sites for the that mention the benefits of using a heat pump?
Yeah, I mean, our website, if you go to the resources page, there's about 50 articles, and some of them, and then there's hundreds more that have come up. Yeah, there's a plethora of information available about how heat pumps work, and there's some of it is not clear about what technology they're talking about, but there's a lot of information out there about heat pumps nowadays. So if you're somebody that likes to read articles, you could go for days.
Okay. There was a comment about, are there heat pump water heaters you can program to turn off and on like you suggest? This person has a Bradford White that isn't programmable. So I just mentioned that they are developing an add-on Wi-Fi module. I have one on my Bradford White in my house, and I'm not sure if it's available to the public yet, but if not, it should be very shortly. So they're trying to get all their units to be able to be controlled remotely as well. And then I think any of the newest heat pump water heater brands that are out there, including the Bradford White, have it built in, at least the ones being sold in California. So they should pretty much all be Wi-Fi capable. So you take that and you go on the phone app and you can schedule when you want the units to run.
Yeah, there's also on those, if you wanted to get really creative, there's different switches and things that you can buy that you can plug the unit into, and you can program it not to run during those times, and it just basically shuts off power to the unit during a certain period of time. So you might want to look for something like that as well if you don't want to wait on the Bradford White controller.
Okay. Let's jump back to the panel question right now. So is there a smart panel out there that can work on 100 amp feed from the street? And I mentioned span and also the Leviton systems, but also that oftentimes we can avoid needing an upgrade altogether by going through a few different switch adjustments. So Larry, if you want to go back on your keyboard a couple slides, maybe 5 slides, we can run through those really quick. For a couple of the solutions. So there we go. If you want to advance through the next 3, we can chat about breakers really quick in the last minute we have here.
Okay. Yeah, so we do this a lot. We do these panel stretching. We call it the watt diet, or it's part of our recipe for good electrification. But there's things that you can do, like if you're putting in a heat pump water heater, there's circuit splitting devices that are available that can help us move loads around. So this particular one is a dryer in one side and a car charger in another. We probably have at least a half a dozen of these out there running the dryer on one side and the heat pump water heater on the other side. So there's these smart attachments, but there's also the span electrical panel is a big one, especially if you're going to do electric car charger, because the way the span panel works is it doesn't look at the car charger in the same way as the other panels do, because it has a car charger that works with it called span drive, and that span drive car charger can actually speed up and slow down depending on how much energy you're using in real time in the house. And also there is the ability for you to program circuitry on and off with that. And the span panel will it has like an override, and it won't let you go over the use. It'll start shedding other loads. I have that same problem at my house right now. I have my wires in the street. I have a 100-amp panel. I have solar batteries, 3 heat pumps, electric dryer, and I want to get the car charger. So I'm putting the span panel in next month so I can do the span drive car charger. And I'm going to be able to do that all on 100-amp feed.
All right. Well, I think that's, let's wrap it up here. So if you want to advance to the last slide or two, and we'll hand it over to April to close this out.
Thank you, everyone. We really appreciate you staying on and listening.
Thank you so much, Larry and Alex. Great presentation, learned a lot. And in case you joined us late or would like to watch again, I will be sending a recording and slides out to everyone within the next week or so. And you can, again, sign up to connect with a participating contractor in the 3C Run single family program at the link in the that I've put in the chat a couple times or on the slides. And I'll also include Larry, I'm volunteering this, I think it's fine, Larry and Alex's email in that email addresses in that follow-up email that I send out, just in case we didn't get to your questions today. They can probably follow up with you directly. So with that, I think we'll call it. And thank you very much on behalf of 3C Ren. Have an excellent rest of your day.
Thank you for spending your time with us today, and we'll see you again soon. Everybody, good electrification.
Right.